Okay, so now I'm gonna admit people in the meantime. Fantastic. Okay, so now it looks like we are almost live. Just give me the final moment to check. For those who just joined us, welcome. We will start in a 1 or 2 minutes. And in the meantime, we're just checking that our streaming format works well. Okay, so just let me check. Yes, okay, now we're live. Fantastic. The stream is working. Good. Okay. Welcome, everyone. Thank you for joining us in such, I don't know, at least in Amsterdam, it's a sunny day. I don't know how the weather is right now in Berlin.
It's also sunny.
It's also sunny. Okay,
Yeah.
so it's common sunny. Fantastic. So for those who the first time joining us, I will provide some more information. Those who are joining us not the first time, like you have 1 minute or 2 minutes more to grab some water or whatever drink you want to serve yourself during this fantastic workshop, and we're gonna start in a bit. By default, the house rules, those who are participating in Zoom, you have options to ask questions, so there is a chat open for you for this. If you have questions, feel free to ask. In case it's something urgent, we can even interrupt Violetta, our workshop giver today, and ask her some questions. And yeah, this is the default. And if you're watching us from the YouTube stream, it means that we basically gonna redirect your questions, if any, also to our workshop giver Violetta. So without further ado, we are PyLadies Amsterdam. We are part of the global group PyLadies, global nonprofit, and our main goal to basically act on diversity and inclusion, and giving the spots for underrepresented folks in tech. And the dream is, when there is no such difference as female data engineer or female machine learning engineer and male, I think that's our job is done. What we usually do, we do monthly workshops. All materials you can find in our GitHub, PyLadies Amps. You see it also on the screen right now. From time to time, we also do some talks, but our main focus are the workshops, and they are conducted whether in online formats like our workshop today, or they are conducted in a hybrid or even just in person. If, for example, the company and the workshop giver do not give us permission to record the session. Sometimes it happens if they want to present something very, very special. So what's expected for today, despite or with together with sunny weather? I guess it's not gonna, it's gonna make sure that you still can follow the workshop. The next almost 90 minutes, you will be here with Violetta. She's our workshop giver, and then by the end of the workshop, while we're gonna finalize everything, there would be some announcement about the next event. So I guess without further ado, I give the spot to Violetta. So Violetta, good luck, and please mute me so I don't disrupt the conversation. Thank you so much.
Sure, muting. Okay, cool. Yeah, so hi everyone, welcome to the workshop. First of all, I will probably introduce myself. My name is Violetta. I work as a solution engineer in a company called DLT Hub. You can see it in my t-shirt, people install DLT. We are a company who has built the library called DLT, which is an open source library for data ingestion. I will talk about it in a minute. About myself, I'm in the IT data topic already for the last, 5-6 years probably. My background mostly machine learning related because I started as a data scientist. I was building machine learning pipelines, training neural networks, and somewhere in my journey, I pivoted to data engineering. So let me first introduce you to the workshop structure. You can see the GitHub repo here, and the main content is in workshop folder. So if you go there, you will see the Jupyter notebook with the content of the workshop. Also, during the workshop, there would be some exercises, and the solutions can be found in solution folder, but please don't look yet. In the README, you can find a way of launching the workshop, but I think the easiest one would be if you just click the link here, which is a link for Google Colab. If you click the link workshop, let me open it in a new tab. Okay. And then just click the button open in Google Colab. I already have it open here. Then I will be scrolling through this Google Colab, and you're welcome to also launch the cells, and I will announce exercises and give you time a little bit to finish them. Again, if you have any questions during the workshop, just please ask in the chat, and I will be answering them in the stream. Okay, then let's start. So the topic of today's workshop is called Open Source Open Pipelines Data Ingestion with Modern Data Stack. So we mostly will be talking about how modern data engineers do the data ingestion, what tools do they use, and especially what open source tools. So as I mentioned, I came from machine learning background, and usually when I worked with data, I had them already in some kind of pre-processed form. Like I either have CSV files or Parquet files, or maybe the data were in some SQL database, and I haven't really thought a lot about how the data end up there. So for me, the dataset just magically appeared, so to say. In reality, of course, there is like a lot of work to make data appear in structured format and to make it ready for people to work with them. So generally, if we split all the data into types, I would say there are well-structured data and unstructured or weakly typed data. So the well-structured data is what you probably worked with, Parquet, Alvaro, or maybe database tables. The idea there is an explicit schema of the data, there are data types, and structure is predefined in advance. The second type is unstructured or weakly typed data, which does not have defined schema. Probably you worked with JSON files where fields might be inconsistent. You don't know the names sometimes of the columns. Some fields are nested, missing key details, and etc. So those weakly typed data usually need to be pre-processed before analysts or machine learning engineers can work with them. So as a data engineer, your work is to be that magician and may take those well-structured data and unstructured data, pre-process them, and make it appear in the destination. Usually, data pipelines work in 3 steps: extraction, normalization, and loading. And during today, we will look at those steps and learn how to work with them. But before we go through all the steps, let me introduce you to this kind of scary-looking schema. I did not draw it myself. I stole it somewhere, but the idea behind the schema is how the data pipelines usually look in modern companies. So there are like 5 steps here. Sometimes they're a little bit different, but generalized version is this. First is collect, then you ingest data, then you store them somewhere, compute, and consume. Let me just give you a quick overview of that. So the first step, which is collect, usually data is not stored in some one source. Usually data is scattered across several ones. Sometimes it could be an SQL database of a backend application. It could be REST API data. It could be files stored in Google Drive, all kinds of different sources. And the job of data engineer is to collect them all and gather in one place. Then the ingest step. So during the ingest step, all the pre-processing can happen. Like if you don't have a structured data, if you have weakly structured data or unstructured, in the ingesting part, you can introduce the schema of the data, you can figure out what the types of the data, do some small cleanup or pre-processing, and put them into storage, which brings us to the third step, the storing. Usually it's either data lake, data warehouse, or the modern one is data lakehouse. So what's the difference between them? In the data lake, usually data stored in files, can be Parquet files, even JSON files, CSVs. In the warehouse, you have your database structure with tables, and in the lakehouse, you can have kind of a mix of both. The raw data stored in the files, but at the same time, you have a metadata layer, which gives you an ability to switch between needed files faster and search for files faster. The fourth step here is compute. So once you have your data in your storage, in your warehouse or lakehouse, you can process them batch by batch, so in like large chunks, or you can process them in streaming. And finally, they consume. So any data science, data analyst, or machine learning engineer work starts there. They just take the data and start building their insights. So our work as a data engineer is to build those pipelines in a scalable and resilient way. So it's not break, it's all work seamlessly, and then enable data scientists, data analysts, and business analysts, and etc. Okay, so during this workshop, we will be discussing how what like challenges there is about building robust, scalable, and self-maintaining pipelines. What is the best practices, and how to do it. And we specifically will be focusing on extraction data from REST APIs. But before we go to the code, I would like to say a couple of notes about open source, why it's matter in data engineering, and what are the available tools here. So open source is not just a license, it's a mindset. It's about collaboration, choosing collaboration over competition, and transparency over black box solutions. And if you choose open source, then what you get is, first of all, flexibility and customization, because you're not locked into one vendor, but instead you can have a control over the solution. You can tweak it, extend, integrate, and etc. The second thing is, of course, you can have the power of community and collaboration. You kind of like work with the best minds in the industry, because everyone can look at the source code, everyone can suggest something. The third thing is, of course, transparency, because you have the code, you can see it, you can see what's happening, how the things works. There's no black boxes there. And of course, costs, because open source is free, and you can significantly reduce your infrastructure spend. Some of the useful open source data engineering tools. So first of all, of course, DLT. I'm saying it first because I work in the company who built this tool. So I will tell a little bit more down the road, but DLT stands for Data Load Tool. This is an open source Python library for data ingestion. Then another tool which we will discuss today is DuckDB. This is a kind of like new age, really fast analytical database, which makes it really easy to set up, develop something, maybe prototype, and etc. So instead of like figuring out how can I install Postgres and start it on my laptop, you can just do pip install DuckDB and start with it right away. Then the next tool is Apache Iceberg. This is not a tool, this is an open table format for big data, mostly analysis. And currently in the modern data lakes, this is a backbone of data lakes. We will talk about this as well. Then there's a tool called dbt. If you worked with SQL, if you worked as a data engineer, you're probably familiar with this. It covers transformation layer, and it's just a way to organize your SQL queries much better. There are tools like Airflow and Duckster, which are platforms for orchestration, which lets you schedule your data workflows. And there are tools like Apache Kafka and Redpanda, which are tools for event streaming. There are a lot of other tools, of course, but I think those are like to-go toolbox of data engineer. So in today's workshop, we will be mostly focusing on DLT, DuckDB, and towards the end of the workshop, we will work with Apache Iceberg just a little bit if we have time. Okay. Yeah, so let's start with data ingestion steps if there are no questions at this point. Cool. So as I mentioned before, the data ingestion requires three main steps, which is extracting, normalization data, and loading the data. So extracting stands for itself, right? You need to extract data from various sources. It could be, again, REST APIs, it could be databases, it could be files, but you need to extract data from there. The normalization stands for all your cleaning of the data, figuring out the schema of the data, what are the data types, all the column names, maybe a little bit of transforming. And the loading, the last step, is when we cleaned our data, we need to load them to our data warehouse or data lake. So let's start with extracting of the data. This would be the first part. So in data engineering, 99% of the data usually stored in either SQL databases, APIs, or files. And in this workshop, we'll be covering APIs because they're the most like messy source of the data, but at the same time, they're the most common type of the sources. There are several types of REST APIs, It could be REST APIs, RESTful APIs, it could be file-based APIs and database APIs. We will be focusing on REST APIs. And when you're extracting data from REST APIs, you would need to keep in mind several different challenges, such as hardware limits, be mindful of memory, of storage, network reliability, because in a lot of cases, network can fail if you request something, like retries, you need to do this, and etc. And API rate limits, because if you're requesting something, usually the REST API has restriction on the number of requests you can do in a like given time, in a minute or in an hour, etc. So before we go deeper into challenges, let's just briefly look at what REST API is. Probably most of you know, but for the sake of those who don't, REST API is the most common ways to extract data, and they allow you to retrieve data through HTTP requests. So, for example, if you work with Python with REST API, you probably will use the request library. Let's run this cell. I suggest you run it as well, so you follow up with me. So what is happening in this code? We're using the request library, and we're just using the get method to send a get request to this URL, which is an API of GitHub. Basically, we're requesting all the repositories in the DLT hub organization. So, for example, if you go directly to the GitHub, no, sorry. For example, here, if you go to GitHub organization, you will see the list of repositories. I will probably have more of them than you because I'm part of this organization, but we can request the same through our request library. This is what we did here, right? Then we just used the JSON to see the whole, to transfer transform the response to JSON format. And we just print out the first two items of the list. So you can see here a lot of different keys. Basically, it's just regular JSON format. And this is, you can also see that there are some nested data here inside. So it's not really well structured, right? And our job will be to transform that into relational format. Let's look at the schema. So what are the common challenges of the requesting data from API? So first of all, the authentication. This one we haven't done right now because this API is public, so everyone can go there and just request this. But in real world scenario, usually the API requires authentication. So the same way, if you go to any website, you would be asked to put your name and password there. The same way it works with REST APIs. There are several different types of authentication. It could be API key, it could be OAuth token or basic authentication. Different APIs has different way of doing it. The second challenge is pagination. So usually when you request data, you don't get the whole data which is available. You only get part of it, like a chunk. It's called page. And if you want to request the whole data, you would need to iterate through all the pages. The problem here is that every single API can implement the pagination differently, and there are several different types. Like, for example, some API requires you to send the page number. Some of them has a pagination in the header, and depending on the API type, you would need to figure out the pagination needed in this particular case and implement it yourself. The third thing is rate limits. Because you're requesting multiple pages, usually all the APIs has limits. They restrict the number of requests you can do in a given time to prevent the DDoS attacks, for example. And then you would need to handle it as well. You need to pause requests from time to time, or you would need to read the retry after header in some cases. But again, for different APIs, it's implemented differently. And the last thing here is memory management. So of course, if you're requesting a lot of data, you cannot load them all into your RAM. Usually the resource where you're running your ingestion pipelines are restricted. Like, for example, in this Google Colab, we can see that there is like some number of gigabytes is given to us. It's like 12 gigabytes of RAM and 100 gigabytes of disk. So we need to be mindful about that and do not overflow. Otherwise, our pipeline will break, everything will break, and data analysts will not get their data. So let's get ourselves one example of pagination, how we can implement it ourselves. And here in this workshop, we will be working with two different APIs. The first one is JaffleShop API. I don't know if you're familiar with DBT, you probably heard about this dataset. So there is like an open source dataset called JaffleShop. It's made up, so the data is not real. It's supposed to be like a shop which sells jaffles. And what we've done in GitHub, we took this data set and just hosted it as a REST API, so we can use it in our learning examples. And the second REST API we will be using today is a GitHub REST API, but we will talk about this in a minute as well. Okay, so let's start with JaffleShop API. If you want to see the docs, you can click on this link. Yes, I would like to go there. So what we have here is just the list of endpoints which are available. So in this API, you can request a list of customers, orders, items, products, supplies, and etc. And we'll be doing this first with orders. Then also in this API doc, you can see like how you can request it, not only endpoints, but also what parameters you need to pass. Here, for example, like it takes parameter called page and page size. Then you also will see the example of responses. Sometimes it's just like super easy JSON. Sometimes it's a little bit more complicated. So yeah, all documentation about this API is here. And what we need to do is request the data. We will be requesting data for orders and implement the pagination ourselves. So if we go and look what are the orders endpoint, you will see that it requires the page number. We can also pass the start date and end date. We will not do it just yet. So we just will pass the page number here. So the pagination would be easy in this case, right? We will have just a true cycle, true loop, where we iterate over page number, and for each page we will request, we will send a get request, get a response in JSON format, then increase the page number, and just print, in this case, page data. Let's run it. So here I am just printing out 2 pages. So I just like break the loop after 2, because otherwise it will take a lot of time. There are a lot of pages in order. So basically, yeah, for each page we get a list of orders. We can scroll through them, but you can see a lot of data. But this is a basic like pagination example here. Hopefully it's clear, but if you have questions, just ask them. Okay, so this was a pagination example, and maybe let's see how we can do it more kind of optimized way, because we were talking about how we need to be mindful about our resources and memory. So instead of just adding like all the pages, like for example, in one list and keeping them all in RAM, we will be building a generator here. So we will request data page by page until we hit an empty page, and then we will yield each page of the data. So I think you are familiar with the generator concept in Python, but the idea here is that we put a function, and inside the function we have our code when we're requesting new data, and then we're building each page by page. So if we go look inside this code a little bit deeper, we have a function here which I call pagination getter. Then we start again with page number 1, and then we have almost the same loop we had before. While true, we just send a get request to the same URL with the page number. Then we get the response in JSON format, print out some logs, and then yielding the page. If we hit an empty page, then we know there's no data left. So then we can use this generator as any generator in Python and just iterate through all the pages. But again, in this particular code snippet, I will break after first page. Otherwise, we will need to wait like a long time. Cool. So we also here printing out the length of the page to understand how many records in one page. Here you can see that it's 100 records because it's default page size. Cool. So this would be the code for us to just gather data from one endpoint. And some of the challenges we haven't overcome here, right? Because we haven't take care of the rate limits, for example. And at some point, server can say, okay, there's just too many requests. And in order to not like do and figure it out for every single REST API, the main advice here would be to use the special tools for extracting data from REST APIs. And I'm talking about the one tool specifically, which is DLT. And what DLT will give you if you use it, instead of just like coding everything from scratch, it will first keep memory usage low because of leveraging parallelism. It will take care of pagination. It will take care of rate limits. It will take care of authentication and all the errors you might have. So let's start with using DLT. First of all, we need to install it. So because it's just an open source Python library, we can do it with pip. So just run this cell, pip install DLT. You can also see here the extra, DuckDB extra. It's because we will be using DuckDB as a destination, but I will talk about this in a moment as well. So how extracting data with DLT would be different from what we just saw. So let's use again the same API, the same orders endpoint, but now use DLT inside. So in our function, which is the same name, pagination getter, instead of just coding ourselves the while loop, we will be using the REST client, which we imported from DLT. And this REST client have a pagination method inside already. So when we initialize it, we need to pass our base URL, which is a URL of our main endpoint, basically, for our API. And then we can define the pagination strategy. By the way, this is not required because in a lot of cases, DLT can detect the pagination itself, but you also can explicitly say what the type of pagination here is. In this case, we saw like this page strategy, but also in the response in the header, we will have a link to the next page. That is why we're using here the header link paginator. And then we just can iterate through all the pages using the paginate method. So we define the client, then we use paginate method and just connect to the orders endpoint. And again, yield pages because we're still working, we're still building a generator, right? Okay, let's run it. Again, I'm breaking after the first page just for the sake of time. And yeah, we saw the same output we've seen before. Basically, we've done the same, but with different tool, right, with DLT. So what you can see here is first, you haven't need to code the pagination yourself. Also, it keeps memory usage low because it's streams yielding data chunk by chunk. Also, this REST client inside will handle all the rate limits and retries. It can handle like all the retries after headers. It can handle like the waiting between requests and etc. Yeah, and regarding destination support, we will talk about this later as well. So in the DLT documentation, you can read all about what the paginators are available there. And as I mentioned, in a lot of the cases, DLT can detect the paginator itself, so you don't need to provide it explicitly. But if you want, you can do it as well. So this brings us to the first exercise, which I want you to do. I suggest you do the same function we have here, like paginated getter, but instead of requesting data from Jaffle Shop, let's request data from GitHub API. I suggest we request data from one publicly available endpoint called repos. If you click this link, you will see the docs available, or you will see redirect. Docs available for the GitHub REST API documentation. Basically, there are a lot of different endpoints. We'll be just working with some of them. So in this case, I suggest you use this endpoint for listing public repositories in your organization. You can also click this link to see the description of this endpoint, how to request, what type of pagination should be used, what type of parameters you can send there as well. And yeah, so the exercise would be just you have here like a code snippets, which is not finished, and just finish it and see if you can get your data. I think 2 minutes would be enough for this exercise. Maybe, yeah. I will give you a little bit more time because this is the first exercise, and I want you to like set things up. If you finished the exercise, maybe just write in chat like a thumbs up or something like I finished, just to get some kind of feedback because I don't see you. I don't know if you've done already. Okay, I see someone has not found URL problem. So yes, why this can happen is this: if you go to the description of your endpoint here, you will see that the endpoint itself is actually not just api.github.com, but then /orgs. Then you need to put some organization there. And I suggest we put like DLT hub and then repos. So if we just request something from api.github.com/repos like this, we will indeed get the error that this endpoint does not exist. So instead, you would need to add like /orgs / the organization name, which I suggest we use DLT hub, and then only then repos. I see some thumbs up. Maybe if you haven't finished it yet, we can do it together, right? So yeah, first of all, as we already discussed just now, the full endpoint is here. So if we will iterate in our pages, we would need to do client, paginate, and then we need to put the endpoint. It would be base URL plus our endpoint. So we just can copy paste this. And to pass the actual name of organization, I can just put here the organization, right? Yeah, and that's all. The paginator, as I mentioned, we can just skip it, to be honest. Let me see if DLT can detect it for GitHub. Let's see. Yes, you see, DLT hub is able to do it. But if you want to set up your pagination in like explicit way, in this case, GitHub using the same pagination type we just used before, so we can just copy paste it from here. Boom, and then header link paginator. Let's check if it's working. Nice. So basically, we've done the same for the new endpoint. And if, for example, we want to request something else, not just repositories, we can do the same with the same like loop, but just put different endpoint here. Cool. So yeah, this was the extracted part. Again, if you have any questions, please ask in the chat. And we're moving to the normalization part. So once we get the data here, for example, if you look at them, there would be a lot of like nested fields. Some of the data can contain like timestamps which are not formatted. We also need to figure out the schema of the data and etc. So all these things is happening during the normalization step. So basically normalizing data here would be structuring and standardizing without changing the content of the data. So what we usually do during this like normalization or data cleaning? First of all, we're adding types. So for example, when we're requesting data from JSON, everything comes as strings. But we know for some specific columns or some specific fields, we know that there are numbers there or timestamps there. So we need to convert strings to like specific data types. The second thing, we sometimes want to rename columns. So to ensure our names follow the standard format. Some databases, for example, forbid to use, I don't know, spaces, which is not good, but one of examples, some of them using the camel cases, some of them only using the all caps or something like this. So basically you need to ensure that your naming convention is one which you choose, and you follow the destination rules. Then, of course, if you have in your responses some nested dictionaries, you would need to bring the values from the nested dictionaries into top-level rows. And if you have lists or arrays, you would probably want to convert these lists into child tables instead of just keeping the whole list as a one field. So yeah, question, why does not use JSON directly? So JSON is a very good format for data transfer, but it's not really easy to work with for data analysts. First thing, why it's not? First thing is there's no enforced schema, so we don't always know what fields exist in a JSON document, especially until we read the whole document, right? Then inconsistent data types. For example, if you have a field called age, it could be a number like 25, it could be a string 25, it could be a decimal. And if you have downstreams application which works with this data, they can just break. Yeah, it's hard to process. It's also memory heavy because if you store your data in JSON files, you would need to read the entire file into memory. And it's very slow if you want to search something or do the aggregation. So let's see how we can normalize data in different examples. So if we just print out what we had before in our page, we can see that this is one response, right? This is only the first item because we took the page data and printed out the first item. So you can see that there are nested things. There are a lot of like timestamps, some, I don't know, yeah, some of them are numbers, but some of them are strings and etc. And what we need to do is to like flatten this all and pre-process it. Again, how we can do it. So sometimes we need flatten nested structure. In this particular example, we don't have it, but in real world scenarios, we often do. Like for example, let's say in our response, we would have a coordinates for start and for end. if we like talk about like some kind of application for, I don't know, like courier delivery, for example. And in this case, we don't want to work with this native structure. Instead, what we want to see at the end is just for fields, right? The latitude for start, the longitude for start, the latitude for end, and the longitude for end. So we need to convert such nested structure into flatten one. The second thing which we usually do is converting timestamps. So it could be stored like in different formats. It could be Unix timestamps. It could be, for example, two different fields, one for date, one for time. But what we want to see at the end is just one formatted. Usually it's ISO, data time string. Then unnest the items. Like, for example, in our Jaffle shop, if you look at the response from the API, you will see that in item field, you have a whole list of different items. And usually what we want to do is not store this list directly, but instead we move them to a separate table. Yeah, instead of doing all these things like manually and figuring out for every specific case, of course, we want to use a tool which will do it automatically for us. And DLT will do this. It will detect the schema. It will flatten all the nested JSON, handles data type conversion, also like split lists into children tables, and supports schema evolution. So let's have an example. This is one of items from our Jaffle shop orders endpoint. And let's see how DLT will normalize this data. First of all, we launch this cell. And then we will use DLT to trigger the automatic normalization. In order to do this, we will start DLT pipeline. So let me explain the code. First of all, we import DLT, which is a library, right? We just import it. Then we define our pipeline, which will handle our automatic normalization. What we put inside the pipeline. First one is a pipeline name, which could be anything you want. Then our destination. As I mentioned, here we will be using DuckDB database as a destination. It would be created automatically, so you don't need to worry about this. You just provide the name of the destination. In this case, it's DuckDB. Then you can pass the dataset name. Again, it could be anything you came up with. And this is our data pipeline. Then to run this pipeline, we need to call the run method and pass the data. So in this particular case, in the data, I put here, right? I put the list with only one item. So we can see how DLT will normalize it. So in this run method, we're passing the data. Then I also passing the table name, one table two called orders. Yeah, the right disposition, we'll talk about this later, but for now, just let's leave it as is. Okay, let's run this pipeline. I think I zoomed out a little bit. Okay. Cool. So what we can see in the logs that pipeline load step was completed. One load package will load into destination DuckDB. And then we also can see the location of our DuckDB database. If we go in our Google Colab, if we go to the files here, oh, I ran it for several times. You can see a lot of DuckDB database in my Google Colab, but you will probably see only one, which called my Jaffle data DuckDB. So it was created automatically. It will be kept in your local disk. So very convenient. What we can also do is to print the trace of the pipeline. Let us do this to see what exactly happened inside when we run the pipeline. So we can see that several steps were run. First step was extract, which we discussed before, right? Requesting data, going through pages, and etc. Then the step normalize. which were completed in 3 seconds. And this is where the normalization happened, where the data were nested, the schema were identified, and the data types as well. And then there was like a step called load to actually take this data and put it into DuckDB. And if we print out what we get in the end, we can do it with command pipeline.dataset. We will see that we have 2 tables here. First table called orders, which is the main table, right? With only 1 record here because I only put 1 item. And then it also created the child table called orders items, which will contain the nested structure. So if you remember, if we go scroll up to the actual data, we had here the items, which is a list again of a JSON. So DLT can understand this is a nested structure and create a child table for it. Okay, so the main take away here from the normalization step is that if you're using special tools like DLT, for example, the normalization will be handled automatically for you. And then we go to the loading data step, unless there are some questions. Okay, cool. Okay, so loading the data. Let's first discuss how the loading will happen without DLT. So if you don't use a special tool, what you need to manually handle is schema validation first. So because in your destination, you have a strict schema, which you need to comply with. So you need to validate if your data, which you received just now, is complying with the existing schema. Then you should handle manually the batch processing because you cannot just take all the data and put it in one run to your database. Of course, any errors handling and retries, and you need to handle it for your specific destination. Like there are a lot of different databases you can use it as destination. Could be Snowflake, could be BigQuery, could be Databricks, could be Postgres, could be MySQL, etc., etc. And you would need to create it for a specific warehouse you're using. So in this case, we'll be, again, loading data to DuckDB. And maybe this is a good time to talk a little bit about what this is. So as I mentioned, this is an open source database, which is very fast and very lightweight. So one of the advantages of DuckDB is, first of all, there is no need to set up anything like server, installation steps, and etc. You just can do pip install DuckDB and then use it right away in your Python script or notebook. It's also very fast. It's optimized for analytical queries like group by, join, and etc. And from time to time, I constantly see some kind of all data community is talking about, hey, have you seen the DuckDB is so fast that it's faster than ABC? So for example, I put here one link how in Hacker News, suddenly everyone were like, hey, have you seen if you use DuckDB to process your CSV files, then it will be faster than double C command, and etc. So yeah, this is very fun to watch, but yeah, just keep in mind that DuckDB is quite fast. It also can work directly with files. You can read directly from CSV, Parquet, in-memory, Python, and etc. So it's very easy to start work with. And it's great for quick testing, data exploration, prototyping data pipelines, anything that works locally. So just to give you kind of an illustration of how DuckDB can be used, let's do this like little exercise here. So there is like a public JSON with movies data available. If we click it, we can see that this is just a JSON, which contains a lot of different movies with title, year, like some cast, description, list of genres, and etc. and etc. And it's very long. You see, my Chrome cannot like load this whole thing. I will not try it. So if we're using DuckDB, we can actually read directly from this JSON file and really easily see the most popular genre here. So we do the select of the genre, group by this genre, and just print out the first top five genres which we have. Let's try it. Again, DuckDB is optimized for Python users, and that is why we can just use it on top of JSON files. In most of the cases of destinations, in most of the warehouses and databases, it's not the case, of course. Yeah, and with DuckDB, you can do a lot of different things. Like, for example, instead of running your SQL queries on top of Snowflake or BigQuery or Databricks, which can be quite costly, you can create local DuckDB databases and run query on them on top of your remote warehouse. So yeah, we can see that it was quite fast, and we can see the top 5 genres, and of course the first one is drama. Okay, nice. Cool. Yeah, this was just a little example of how you can use DuckDB in your work. Let's take a look at how would we load the data if we don't use special tool like DLT. What we need to do then, we would need to connect to our database. Then we would need to create our table. Like if we were loading orders from Jetful Shop, we would need to create a table called orders. And yeah, since in the nested structure, we do need to do normalization ourselves before, of course. So we need to create a schema of this table. You see, I am creating here all the fields, all the columns with specific data types. Then we need to insert data, of course. So in DuckDB here, with this command, for example. Yeah, and then to just query them, we can do select. So in case of different APIs, you would need to do it for every single one of the table, for every single endpoint. And also the schema management would be here manual. So if schema is changing, you need to go to your script and change your column names, data types, or add new ones. Also, there's no incremental loading, so you need to take the data first and then insert them. Yeah, basically it's just a lot of code to maintain. So if you're using special tool, of course, the load step will be handled automatically. So with DLT, it will support multiple destinations. So you not only can load data to DuckDB, but also to any destination you have. It also using batch loading parallelism for fast loading of the data and scalable. It manages the schema changes also automatically. So it ensures that all column names, all data types, all structure match the destination requirements. Also, it can load data incrementally, and again, take care of all the retries to make sure your pipeline is resilient. Okay, so yeah, let's load data into DuckDB with DLT. So here we will be using, again, the Jetful Shop example. I just creating the function called Jetful orders and just copy pasted the previous code here. What's new here for you is this decorator called dlt.resource. This is an internal structure of DLT, which helps you to take your Python functions and turn it into a DLT resource, basically a resource of your data. You can use this decorator with any Python functions, which is a generator, which is yielding the data. So yeah, we just put it on top of our Jetful orders function. Here, the code is already familiar to you. So we use, again, REST client, passing our URL. using header link paginator, and then paginate over the orders endpoint and yielding the data. So this is our resource of the data. Then we define our pipeline. The same way we did before, dlt.pipeline. Here I only put the destination, but you can also put here the pipeline name. If you work, for example. And then we just run this pipeline and passing our resource. Also, what's new here is using this function called add limit. What it does, it limiting all the requests for like only 2 requests. Because if we load all the data, we will wait for a lot of time. In order to like make it shorter, I just add limit for 2. Yeah, and then we're printing like the load information. Okay, let's run this code. So what DLT should do here, it should go to this endpoint, to this REST API, request 2 pages, because we have here at limit 2, normalize the responses, and load them into our DuckDB. At the end here, I also printed out orders dataset to see like what inside. So yeah, let's look at the output. So we can see that pipeline was completed. Again, the package was loaded into DuckDB database. And then when I printed out our data, you can see here that orders table contains like 200 rows because it was 2 pages, 100 row ish, right? And yeah, done. The data now it stores in DuckDB. And again, what does it mean that schema is managed automatically is that if, for example, API will change, if new column would be added, DLT will automatically create this new column in our destination database. And if, for example, some data type of one column will change from, I don't know, for example, number to string, DLT will also take care of this and it will create additional column of the new type. Cool. So now the second exercise, let's do the same with GitHub issues. So now this is a little bit different endpoint than we had before. The endpoint is this one, right? api.github.com, then repos, then owner, the repo name, and issues. So again, I suggest we use DLT Hub as an organization. So in this case, the endpoint would be DLT Hub here, right? And then any repository, again, I suggest DLT, but you can use any repository in GitHub. And let's just load all the issues of this repository. So you can start with like copying this code, for example, and change it to GitHub related code. But again, let's have like maybe 5 minutes to do this exercise. And if you finished or if you have any questions, just write in chat. Okay, again, let me know if you finished the task. Just write in chat something, or if you have questions. Yeah, I can see the first thumb up. So if you haven't finished, we can do it together, right? So as I mentioned, we can start with like just honestly copy pasting our code. I do this a lot. And changing it for GitHub. So our endpoint, oh, thank you. Copilot. Our endpoint would be issues. So in the REST client, we can put base URL as this one, right? Again, the pagination is the same. Then we need to put the endpoint itself, which would be repos/dot hub/dot/issues, and just yield the page. Then we need to define pipeline, where we can put our pipeline name. Would be GitHub issues pipeline, for example. Then destination would be DuckDB. And yeah, I think this would be enough. And then we just run our pipeline with our get issues source. Okay, let's see if it works. Or maybe I forgot. I forgot to define the header link paginator, but I defined it before, so it's fine. Oh, yeah. Oh, okay. So we can just do this info equals boom. So we don't have like a huge output. And then just print info. Nice. So yeah, so the GitHub issues were loaded. Nice. And yeah. One question was can I just put the base URL with my endpoint here directly, right? Like this. Will paginate method work? Let's check it. Okay, it is working, but why don't we want to do it? Is because if, for example, usually we don't load the data only from one endpoint, but we load it from several different ones. So if I want to do this, I would rather have one client with base URL and then just put different endpoints in my loops. So I can have, for example, second loop where I can paginate different endpoint. And then it would be easier for me. But yeah, you can put it there as well. Okay, I think, yeah. So with these issues, for some reason, I didn't have problem, but usually when you're requesting some data from GitHub and it's a lot of data, for example, then you will probably get an error saying, hey, you tried to request too many different things, and it would be the rate limit request error. So in order to overcome it, we would need to add authentication to our GitHub pipeline. So what does it mean? So now we're requesting data from GitHub repository, but GitHub just giving it away without asking who we are. And in order to add authentication, to add our token, we can go to GitHub, our GitHub, and just create it to use it to tell GitHub, okay, this is me, you know me, please just give me data, right? So let's do it together. We can just go to here, you can see the instructions, but you can just go to your GitHub account. I'll just click this link. there would be instructions, but basically you just go to your GitHub account. Like, for example, I have a link here. Then you go to your settings. Where are the settings? Here. If you scroll down, you will see the developer settings. Here, tokens classic. You will see all your tokens and you can generate a new one. I will show it to you because like usually don't show your tokens, but I will just remove it after the workshop, so it's fine. If you click generate new token, okay, authentication, a bit quick. PyLadies, example. And then you only need the repository scope. You don't need anything else. So you can generate your token, and then you can use this token to request more data, because in GitHub API, the rate limits are different for authenticated requests and for any like public requests. Okay, so how we do this with Google Colab. So Google Colab has this thing called secrets. If you go here, you will see all your secrets. You can see I have a lot, but you probably will have the empty here, and you can create new secret to just keep your like API tokens, username, password, and etc. in a protected way. So if we click add new secret, we just like can call it secret key. I already have it, but let me delete this one and just add a new one. Secret key. And then I can just pass whatever I just generated here. Okay, cool. So now new secret is added and you can use it in your code in your Google Colab. So if you want to add authentication, if we will add authentication, then we will have higher rate limits and we can request more data basically. So this brings us to exercise number 3, and I suggest you to add authentication to your pipeline which you had. So again, if you already generate token, if you haven't, I can repeat the pattern here. You just go to your GitHub, to your profile, go to settings, then scroll down to developer settings, then click tokens, and just generate new token, classic. Never used yet. Then you go to your secrets and just pass it here. So in order to use it here, you need to specify the authentication with this token. I will just give you some time to do this. Yeah, we just have like 12 minutes left. That is why let's just speed up a little bit so we can do this exercise together. So what we need to figure out here is what type of authentication actually GitHub requires. And then select the right authentication method from DOT. So if we go to all the methods here in the link in DLT, we can see that there are several different supported, which is bearer token auth, API key, HTTP basic auth, and OAuth 2. So if you go to the GitHub documentation and search for authentication method, you will see that GitHub is actually using bearer token auth. So we can just like copy paste it from here. So from DLT, we need to import bearer token authentication. And then in our REST client, we have a special parameter called auth, and we just pass here our bearer token. And then we need to provide the actual value of our token. Do you remember that we pass it here in our secrets? So we can get it in collab through user data. Here it's already written, so we just pass here access token. Okay, so the other things remain the same. So if we want to get issues, we just run it. Probably, sorry, I need to add limit as well, right? Because otherwise we will wait for a long time. Let's say 2. Cool. So the data were loaded to destination. Nice. And in our DuckDB database. And if we want to actually look at them, we can also print out our DF which we did before. But let's move on to incremental loading because we only have like 10 minutes left. So what we are doing so far, we're just extracting all the data from REST API and putting them into destination. But usually we don't want to do it regularly, right? So if every time we want to extract new issues, we don't want to extract the whole thing and just reload it. That is why usually in data engineering, we use the incremental pipelines. What does it mean is that we only extracting new or modified data. Like, for example, if you're talking about GitHub issues, we only want to extract the issues which were modified from our last load. If we want to do incremental loading, this would require the keep track of what issues were already loaded, right? Kind of state tracking. And with DLT, it can be done automatically. What we only need to do is to specify our incremental cursor. So, for example, with issues, if we go to the description of our endpoint, oh, this one is repositories, I need issues, right? REST API endpoint for issues. So if we go to our list organization issues, nice. Then we will see that it also has a parameter called since, which only show results which were last updated. So we can use this parameter to only request latest updated data. Let's see. For our issues endpoint, I don't think I opened the right endpoint. I opened, yeah, list repositories. Let me see. Create an issue. Okay, I had a link somewhere here, right? Wait, this one. Yes. List repository issues, right? So here, what are the parameter? Yeah, the same parameter since. Okay, then we use it. Cool. So in order to request only new ones, we need to use this parameter, and we need to specify the incremental variable. So in case of Jaffle Shop, there is an example here. There's like a parameter called ordered at. So we can use the DLT variable called incremental here. We just define it this following way. We put the name of the cursor, and then we put initial value. And then when we use the paginate, we just pass it in our parameters. So for Jaffle Shop, the parameter called start date, we can try this incremental loading for Jaffle Shop. Again, having our pipeline defined, destination is DuckDB, everything is the same. So here, initial value is like 26 August of 2017. It will load some like 5 days, I think, of the data or something like this. So once the data would be loaded, the next consequent runs will not load anything unless something changed, right? So in this case, we loaded like 1,700 rows. But if we run it again, like the same code, the same pipeline run, we will not see new data because the pipeline is stateful and incremental, and it can detect that no new data was added, so no new data needed to be loaded. And while it's loading, I think the last exercise for today would be the loading the GitHub data with incremental loading. So again, the code that we had before, let's change it a little bit to make it incremental. So we can start with like copy pasting our code for GitHub issues and just add an incremental cursor. We can use as an example our Jaffle Shop API. So just pass the dlt.sources.incremental. I think let's do it together because we don't have like a lot of time. So in our resource, we're just passing the cursor date. So the fields to track our timestamp would be a little bit different. We need to go to our API endpoint and see what it is. So if we go to our endpoint, we will see that in example response, we have this updated at cursor, so we can use it. Updated at, I think it updated at, yes. Cool. The initial value could be any. We can keep it as is, for example. And then when we request the data, we would need to provide additional parameters. As I mentioned, we need a parameter called since. And we will use our cursor date. And we will use the last value of it. So DLT will keep track of what issues were already loaded and what was the latest values of this cursor date. So every time you load new issues, it will only be loading the updated. So we can run it. Okay. I think I messed something up. Get issues. Sure, params. Nice. Okay, so yeah, the rest of it, I think we will just skip. But maybe what I wanted to mention is that here we used only DuckDB as a destination, but with DLT you can use different type of destinations, like there are a lot of them supported. And in order to change your pipeline from using DuckDB as a destination to any other destination, you would need just change the name. Like when we're defining the pipeline, we used DuckDB, but then if you want to load data to Snowflake, for example, you will just use here Snowflake and etc. Okay, yeah, so we don't have time to like finish the example with Iceberg and the Sparkit files, but you're more than welcome to do it at home. Also, like any exercises, if you haven't been able to finish them, you can always go to this solution page. And here you will find all the code snippets for all the exercises, basically. Cool. Do we have any other questions?
No. Thanks for the tutorial.
Thank you. It was really nice.
Thank you.
Yes, thank you for joining. I think it was really, really interesting. And now you see how all this messy data delivered to you in the right place and the right time. So thank you for staying with us. By the way, this workshop was recorded, so which means it was streamed directly to YouTube. So feel free to get back if you want to rewatch some piece of it. It would be here. In addition to that, couple of days after the workshop, we are going to add timestamps so you can easily navigate from the workshop materials to the dedicated pieces of video. And as Violetta mentioned, that indeed the last piece would be your homework.
Yep.
But anyway, yeah, thanks for staying with us. So I think to close this event, we already has a lot of interesting things planned for you for the next month. I only gonna first of all want to thank you hugely to Violetta because she basically saved us. Originally, we have another workshop planned. Unfortunately, due to some circumstances, personal circumstances of the workshop giver, we had to find something really, really last minute. So I would say huge, round of applause to Violetta for saving us and basically preparing this workshop within less than 2 weeks. So for your understanding, usually we spend a couple of months to finalizing it, but now it was, yes, like super hardcore extreme workshop preparation, one-on-one. So we are really happy that Violetta mentioned that we invited Violetta to do that. Thank you so much. So regarding the next workshop, I cannot tell you exactly whether it would be online or hybrid. If we secure location, it would be hybrid. If not, then it would be fully online. I only can tease you a bit with what we covered. So we're going to work together with Dapper community. That's mostly Python library for distributed applications. And where we're going to focus on for the next workshop, we're going to focus on using Dapper conversational API and also building agents, AI agents with Dapper. So that would be the topic of the next event. So once again, thank you so much, Violetta. What I'm going to do now, I'm going to stop stream, and then I will gently kick you out from the meeting, except Violetta. So yeah, just thank you so much. See you next time.
Thank you so much.
Okay, so the stream is finished. Okay. Fantastic.